Newton's universal law of gravity states that the force of gravity between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. In this picture, we have two masses, capital M and lowercase m. They are separated by distance r. We choose the origin to be at the center of the first mass. The magnitude of the force vector on the second mass will then obey Newton's law of gravity. The negative sign is connected to the unit vector r hat and indicates that the force is always in the direction of the other mass. By Newton's third law, this also means that the force on the first mass by the second mass will have equal magnitude but opposite direction to the force by the first mass on the second mass. Because the force is proportional to the product of the masses, the force increases if either of the masses is greater. The inverse square law of gravity also means that if the distance between the masses increases, the force decreases as the square of the distance. The proportionality constant, capital G, is known as the universal gravitational constant. It has a value of 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. Here is a calculation example. Calculate the magnitude of the force of gravity on a 70 kilogram person on the surface of the Earth. Here are the relevant variables. Capital G, the mass of the Earth, and the radius of the Earth. Note, the radius must be converted to meters. If we carefully plug this into our calculators, we get a magnitude of 690 newtons. Note that this is equivalent as if we had calculated the weight using just mg. This is because lowercase g, the acceleration due to gravity, derives from the universal law of gravity.